So this is going to be a video about finding the volume of a solid of revolution that's bounded by this y equals negative x squared plus 6 and y equals 2. And the solid of revolution is going to be perpendicular to the x-axis. So it says right here perpendicular to y equals 0. So first thing I'm going to do is kind of graph this to get an idea of what it looks like. So I'm going to graph it real quick. All right, so based on the graph that I just drew right here, you can see that there is going to be like an empty space kind of in the middle of this. So we are going to need washer method. So we're going to have to subtract off whatever the volume of this part is right here. So here we go. I'm going to set up the volume equation for solid of revolution, but I just have to make sure I subtract out this volume right here. Okay, so for my limits of integration, I basically need to figure out what the value of this is right here and the value of what this is right here. Now to do this, what I'm going to do is I'm basically going to be setting the two equations, this negative x squared plus 6 and these two y equations. I'm going to set them equal to each other and solving to figure out those intersection points. So that's what I'm going to do right now. So after solving for these, we got the answer to be x equals plus or minus 2. So I'm going to put that in the graph really quick. Okay, so that's our limits of integration. I'm going to finish out this volume equation here. All right, so the way the washer method works, it's going to be whatever the function is on the outside, so the outer radius. In this case, it's going to be this red one, so it's going to be this x squared, negative x squared plus 6. So I'm going to put that in there first. And then I'm going to subtract off that volume that we're trying to get rid of, this empty space right here, which is going to be the integration of this orange right here, which is the y equals 2. All right, so from here, I basically follow the washer method formula. I squared each of the functions, which represent the radius of this solid of revolution, and I included the pi. It's an easy thing to forget. So from here, the rest of it's just going to be simplifying it and then taking the antiderivative and then plugging in 2 and negative 2 to that antiderivative and subtracting it off. So that's what I'm going to do real quick right now. So from here, I'm going to simplify, and then I'm going to take the antiderivative. So here in red, I have my antiderivative. Now I just need to plug in 2 and plug in negative 2 and subtract those values off. And again, don't forget to multiply by pi. So once you plug in the 2 and the negative 2 and subtract those off and then multiply by pi, you should end up with 384 pi divided by 5 as your final answer. So if you have any questions about anything in this video, let me know.